Dear students, in the last lecture, we started to study the second topic, modulation and demodulation. In that topic, we studied the definition of a modulation, need and importance of modulation. We have studied the types of modulation. When we studied the types of modulation, it is broadly classified into two types. One is analog modulation and second one is a digital modulation. There are different types of analog modulation and also there are different types of digital modulation. Analog modulation is of four types. One is amplitude modulation, second one is angle modulation, next one is frequency modulation, and last one is phase modulation. Out of these four types of analog modulation, today we are concentrating on amplitude modulation. So as we are aware that modulation is the process which is used in the transmitter before transmitting the modulating signal. The modulation process is going to be gets adapted. To understand the meaning of amplitude modulation along with its mathematical background associated with it, so as to give the nature representing the modulated wave and also modulation index. Depending upon the equation of the modulated wave, one can represent the frequency spectrum of amplitude modulation. All these we are going to study under the title known as amplitude modulation. We will start the amplitude modulation with its basic definition. As we have already studied the definition of modulation, and it is modulation is the process in which some of the parameter of high frequency carrier wave is varied in accordance with that of parameter of the signal to be modulated or signal to be transmitted. By keeping this definition in our mind, we can define amplitude modulation. Amplitude modulation is the process in which peak amplitude of the sinusoidal carrier wave is varied in proportional to the instantaneous amplitude of the modulating signal. This means peak amplitude of the high frequency sinusoidal carrier wave. Carrier wave means the wave that carries the modulating signal is called as the carrier wave. Its amplitude is varied in accordance with that of instantaneous amplitude of the signal to be transmitted. Signal to be transmitted means any kind of a signal. Maybe it is audio signal, maybe it is video signal, maybe it is electrical conversion of electrical signal proportional to the any physical quantity. Its amplitude is varied in accordance with that of the amplitude of the high frequency carrier wave. Here we are superimposing the signal to be transmitted as per its change of amplitude. We are changing the amplitude of the carrier wave. This process is known as demodulation, especially amplitude modulation. This process is the same as that of, suppose a small boy is there that carries the information, but the boy cannot travel a long distance. So that's why the boy should be placed on the shoulder of such a person who is able to carry him at a place where the information is to be recovered. And the place where the information is recovered, there a person who carried the boy will place the boy and he will come out of that particular carrying process. And whatever information associated with the boy, it is being collected there. So this is a very good example of the modulation. Now we are going to derive the modulating equation by considering the signal to be modulated is in the form of sine wave, and also the signal to be which is used for carrying the modulating signal is also in the form of sine wave. Let us consider sinusoidal signal with a single frequency that is used for the analysis of amplitude modulation. So just to start with the analysis of this same, let me consider EM be the modulating signal represented by capital EM sine of omega mt, where capital EM is peak amplitude of the signal to be modulated and omega m is the angular velocity of the signal to be modulated, which is being represented in the form of sinusoidal wave. Analogous to that, let me consider EC with a carrier wave, which is equal to ECM sine of omega ct. Capital ECM represents the peak amplitude of the carrier wave, whereas omega c represents the angular velocity of the carrier wave. The difference between the signal to be modulated and the carrier wave is that carrier wave possesses the high frequency, whereas the signal to be modulated possesses the frequency as per the signal variation that takes place. Both these equations contains the variables, those are being explained here, where omega m is and omega c are angular velocities of the modulating and the carrier signal respectively. Capital EM and capital EC are maximum amplitudes of the modulating and the carrier signal respectively. When this modulating signal is superimposed on the carrier wave, that means after amplitude modulation has been takes place, As per definition of amplitude modulation is being considered, the amplitude of high frequency carrier wave means this wave is varied in accordance with that of instantaneous amplitude of the signal to be modulated or signal to be transmitted. With that particular definition, we can say after modulation, peak amplitude of the carrier wave increases so that modulated wave is represented in the waveforms which we are going to present in the next slide. When this is after modulation, peak amplitude of the carrier wave is increases or decreases as per amplitude of modulating signal. So that modulated wave is represented in the waveforms which we are going to study in the next slide. Means this implies that after the modulation process is over, peak amplitude of the carrier wave either increases or decreases. That depends upon amplitude of the signal to be modulated. So just to proceed further, we can say after modulation, the modulated amplitude means variation in amplitude of the modulated wave is given as ECM means amplitude of the carrier wave plus EM sin of omega mt. So this amplitude carrier wave changes with the change in amplitude of the signal to be modulated. The modulated output voltage, output signal is given as capital E modulated into sin of omega ct. Putting the value of capital E mod in equation number 2 from equation number 1, we get modulated output voltage is equal to ECM plus EM sin of omega mt into sin of omega ct. Which can be simplified as, so we have to multiply the whole bracket by means of sin of omega ct, so as to get ECM sin of omega ct plus EM sin of omega mt into sin of omega ct. By taking ECM sin of omega ct common, we can write ECM into bracket 1 plus EM upon ECM sin of omega mt into sin of omega ct. Which one can write it? ECM into bracket 1 plus MA. Here is a new term which we are getting it into sin of omega mt into sin of omega ct. So equation number 4, where MA is called as modulation index of amplitude modulated wave, and it is given as the ratio of EM upon EC. MA is also called as modulation factor, or it is also called as depth of modulation, which is defined as it is a ratio of maximum amplitude of the signal to be modulated upon amplitude of the carrier wave. That is, ratio of EM upon EC is called either as a modulation index or as a modulation factor, or it is also called as depth of modulation. So equation 4 represents the equation of modulated wave, that is E mod. We have the equation of modulating signal in the form of a sine wave. We have equation of carrier wave in the form of sine wave, and we also have the modulated equation being represented by means of an equation number 4. By using equation of modulating signal, by using equation of carrier wave, and also by using the equation of modulated wave, we can represent the process of amplitude modulation. It is being represented in this particular slide. When you plot the waveform which are the function of the voltage, the signal to be modulated versus time, you can plot the carrier wave voltage versus time and the modulated wave amplitude versus time. Now the first wave represents the signal to be modulated, that is Em is equal to capital Em sin omega t represents this particular waveform which is sinusoidal in nature. The second wave is the carrier wave. It is represented by Ec is equal to Ecm sin of omega ct. When, if you look to the waveforms, the frequency of signal to be modulated is less because time is more. As far as carrier wave is being considered, its time is less. Hence the frequency is more, and that's why we can call carrier wave as a high frequency carrier wave, whereas the signal to be modulated has a low frequency. This low frequency signal to be modulated is superimposed over this carrier wave. Means as amplitude of modulating signal changes in the modulated wave, the frequency of carrier wave also changes. Amplitude of the carrier wave also changes, which we can locate in the modulated waveforms, which is being represented by the equation 4. If you look to modulated wave, that is E mod, one can say that as the amplitude of modulating signal increases, the amplitude of the carrier wave also increases up to here. So where the amplitude is maximum. When the amplitude of the modulating signal decreases up to here, naturally the amplitude of the modulated signal is also goes on decreasing. Again, when amplitude of the modulating signal increases, naturally amplitude of the carrier wave in the modulated signal also increases. This process is going to be gets repeated. Thus, this particular waveform we can call it as it is amplitude modulated wave, possessing E maximum here and E minimum here. By knowing E maximum and by knowing E minimum, we are going to calculate the modulation index of the amplitude modulated wave. Once again, try to remember As the amplitude of the modulating signal changes, in the modulated wave, amplitude of the carrier wave also changes. If it increases, amplitude of the carrier wave in modulating signal also increases. When amplitude of the signal to be modulated decreases, in modulated wave, amplitude of the carrier wave also decreases. In the definition, we have studied the same thing, and that is amplitude of the high frequency carrier wave is changed in accordance with that of instantaneous amplitude of the signal to be modulated. As per definition, we are obtained the modulated wave. To move further from that particular modulated wave equation, we can write modulation index, which I have already defined. It is the ratio of EM upon EC. We can also define modulation index as EC max minus EC upon EC. EC max means amplitude of maximum amplitude of the carrier wave, and EC means any instantaneous amplitude of the carrier wave. It can also be defined as it is a ratio of EC minus AC minimum upon EC. Means if you take the difference between amplitude of the carrier wave at any instant and minimum amplitude of the carrier wave, if you divide it by instantaneous amplitude of the carrier wave, the resulting equation is going to give again the modulation index. The modulation index is also given as E maximum or EC maximum minus EC minimum upon 2 times EC. This is also a valid definition for the modulation index. One can also write it EC maximum minus EC minimum upon EC maximum plus EC minimum. Thus equation 5, equation 6 and even equation 7 are used to calculate the modulation index. By multiplying 100 to modulation index, we get the modulation index in percentage. Thus, we can write modulation index as EC maximum minus EC minimum upon EC maximum plus EC minimum into 100, that is in percentage. Same formula we are using in practical to calculate the modulation index of the amplitude modulated signal. Friends, here one thing I am going to say, we have an experiment of amplitude modulation. It is to be performed by you in the laboratory. In laboratory also, you should going to observe this particular type of the waveforms on the CRO. On the CRO, you are going to measure E maximum and also E minimum. By knowing that, one can calculate the modulation index also. Now by using equation 3 and 4, means by using equation 3, this is the equation 3 and this one is equation 4, we can write E modulation as ECM sin of omega ct plus MA by 2 ECM cos of omega c minus omega m into t minus MA upon 2 ECM cos of omega c plus omega m into t. Say equation number 8. Equation 8 can be obtained by using equation number 3 and 4. Please try to remember. From equation 8, we can say that it represents three terms. It is also same as that of modulated equation. From that only, from modulated equation only, we have derived equation number 8. That includes now the three components. The first one represents the carrier wave component, which is here, that is ECM sine of omega ct represents the original carrier wave. Next term is MA into ECM, MA upon 2 into ECM cos of omega c minus omega m into t. That means this term. So which is represented here, MA into ECM upon 2 cos of omega c minus omega m into t. It has a peak amplitude of MA into EC by 2, means this term we can call it as it is a peak amplitude. And frequency is the frequency difference between carrier and modulating signal, means omega c minus omega m is the frequency difference of that particular signal. The third term is minus MA upon 2 into ECM cos of omega c plus omega m into t. That means this term. Minus MA into EC by 2 into cos of omega c plus omega m into t. This term has a peak amplitude minus MA into EC by 2, which is opposite in phase, indicating that it is opposite in phase. Whereas the frequency is the sum of carrier frequency and modulating frequency. Look at here. Here represents there is a decrease in frequency. Here it represents there is a increase in frequency due to phase change. Thus, from these three terms, we can write the component 2 and as component 1 is the original carrier wave. The component 2 and 3 are known as lower sideband and upper sideband respectively, which are equally spaced from the carrier frequency and having the magnitude 0.5 times the modulation index times the carrier amplitude ECM. Means if you look to term 1, 2 and 3, the amplitudes of term 2 and term 3 is half the amplitude of the carrier wave. So that's why 0.5 times MA into amplitude of the carrier wave. Look at MA into ECM upon 2 means it is 0.5 times MA into ECM. Here also it is 0.5 times MA into ECM. Both are in opposite phase. Both are in opposite phase. First one is called as lower sideband, and next term is called, this term is called as the upper sideband. The first term representing the original carrier wave, second term representing the lower sideband, third term representing the upper sideband. All these are represented in the frequency spectrum. So this represents the frequency spectrum. So it is a graph of amplitude versus frequency. If you look to the three components, exactly at the center there is a FC, that is a carrier wave, which is being represented by ECM sine of omega ct, having amplitude equal to EC or ECM. Whereas the graph to the left side represent the lower sideband, having the frequency equal to Fc minus Fm. That is the difference of carrier frequency minus modulating frequency, with the amplitude half of the carrier wave amplitude. Amplitude of lower sideband is half the carrier amplitude. Similarly, the spectrum to the right of carrier wave will be represented by Fc plus Fm, omega c plus omega m. It has again an amplitude which is half of the amplitude of the carrier wave. So friends, on this frequency spectrum might be some examples are going to ask in the question paper. So it may be with the aspect that the modulated equation is given, and by using that particular modulated equation, it is asked to determine modulation index, carrier frequency, modulating frequency, carrier amplitude, modulating amplitude, and also the amplitude of the lower sideband as well as upper sideband. By knowing that, maybe they are going to ask to plot the frequency spectrum. Thus, we can say, if the signal is amplitude modulated, it has carrier frequency at the center with maximum amplitude, along with the lower sideband having the frequency Fc minus Fm and amplitude half the carrier amplitude. Also upper sideband with the frequency Fc plus Fm and the amplitude again half the maximum amplitude of the carrier wave. So students, please remember this much about the amplitude modulation. And this amplitude modulation is used in the analog modulation in the transmitter. Means the amplitude of the high frequency carrier wave is changed in accordance with that of the instantaneous amplitude of the signal to be modulated or signal to be transmitted. In this period, we will stop here only. Rest we'll see in the next period.